Hello students, this is Mr. Yao. Today we are going to talk about 8.2 where we will learn a second type of conic sections which is called hyperbolas. It is kind of similar to ellipse, so let's review ellipse first. An ellipse is a set of points on a plane whose distances to two fixed points add up to the same value. That's the key. Last time we have learned if this is my ellipse, we kind of have a point, the distance to foci, it will always be add up to 2a. That's what we have learned. The general equation for ellipse, we have two different ones because of major axis a under the x means a horizontal major axis. A under the y means a vertical major axis. So that's why we have two different equations for this. Hyperbola will kind of work the same way. So let's get into the definition for hyperbolas. Here's a link of a GeoGebra demonstration that you can check. Hyperbola is the set of points on a plane whose distances to two fixed points has a constant difference. So it's not they add up to the same value anymore. In this case, the two fixed points are still called foci, but it's going to be their differences that stays constant. Hyperbola just like ellipses, except the branches open outwards. If they open inward, we're going to form an ellipse, but this time it's actually opening outwards. They open in the direction of the positive variables. General equation, as you may notice, the only difference compared to the ellipse equations will be right here. Instead of a plus sign in the middle, it's going to be a subtraction sign. And that is why in the previous sentence it says they open in the direction of the positive variable. So in this case, a is positive with x, a is positive with y. That means the first equation is opening left and right. Second equation is opening up and down. The center will still be h, k. Now let's get into the graphs to generate some hyperbolas. In order to form the hyperbola, we use 4 points from the a and b values to generate a fundamental rectangle. The a and b values will follow their corresponding variables. First, let me write the equation. Even though this is 0, 0, I'm still going to write the general equation. Since it's opening left and right, that means my equation is going to be x minus h squared over a squared minus y minus k squared over b squared equals 0. And in this case, our center is, of course, going to be 0, 0. So h and k would just be 0. Now, where are my a's? My a's is going to be on not called major axis anymore. It's actually called transverse axis. This word is a word that you have learned before. When you were working with parallel lines with a line cutting through, that line is called a transversal line. So in this case, transverse just means it's an axis that is cutting through the hyperbola curves. So of course, that would be right here. This is my transverse axis in this case. And my vertices would always be on the transverse axis, and also my foci. So here's my negative a0, and here's my a0. There's my vertices on the transverse axis. As for my foci, they are going to be right here. So that is my negative c0, and that is my c0. And you may notice my c is clearly bigger than a value-wise. So of course, in this case, it's not going to be c squared equals a squared minus b squared. It's actually going to be c squared equals a squared plus b squared, which is exactly the same as the Pythagorean theorem. So I will show you where that right triangle is when we get after we have generated the rectangle. So the foci would have to be outside the rectangle, which also means the foci would have to be within the curve or the curvature. Now let's actually find out where is that rectangle. I have my a values. My b values would actually be on the other axis, of course. So there's my b values. That would be my 0, negative b, and that's my 0, b. So I have 4 points, and if I extend the points on the level that they're at, there is my rectangle. There we go. I'm going to actually write them smaller right below. That is my 0, b. Okay, and there's my rectangle. The rectangle are formed with a length of 2a or width, and the other side would be a 2b. So now let's find out where is that right triangle. if this value is A and this value is B, I can clearly, or this is A, that is B. If I connect them, there's my C. There's my C. These values are all going to be C. So that means if I actually connect all of these points with the foci, I would actually form a circle with a radius of C. So that is kind of something interesting about hyperbolas. It has kind of this, this major setup. C squared equals A squared plus B squared. Now let's move on. Conjugate axis. Well, that's the axis runs in the direction of the negative variable, which we have already generated, is going to be the B part. So this is my, I'm going to draw it. This is my conjugate axis. So since we have generated A and B, lastly, we have something extra compared with ellipse. We have an asymptote. Connect the diagonals of a rectangle using dotted lines, and these are the asymptotes of the hyperbola. Asymptotes means it's a line that a curve will never actually cross. It's going to get super, super, super close, but it's never going to cross. And the branches of the hyperbola will be curving around the foci and approaching the asymptotes. So basically my red lines would be my asymptotes. I can just extend them on both directions right here. Okay, and if we have a line, of course, we need to know the equation of the line, so let's find out. The center in this case is 0, 0. I'm going to pretend it's not 0, 0. Let's actually say that center is h comma k. In that case, I need to find out my slope. But the slope is actually super easy because the rectangle for this section is a B, that section is an A, so of course my slope would just be E over A. With point slope form, we can easily write the equation for the asymptotes. Y minus K equals, the slope is B over A times X minus H. But that is just a positive direction. We also have the other one, but the other one would just be a B and a negative A. So we're just going to put a plus minus in front of B over A, and that will give us both asymptotes. And again, this is called a point slope form, which means as long as we know a point on the line and we know a slope, we can actually easily write out this equation. It doesn't have to change into slope intercept form. We can just use that. So now let's actually get to the other equation, the other direction of the hyperbolas. For this one, the general equation would be y minus k squared over a squared minus x minus h squared over b squared equals 1. So in this case, that is my center, and my major axis, my transverse axis would actually be vertical right here. That means my points, that would be a 0A, and that would be a 0, negative A. Now, moving on, let's find out where are my foci. My foci will always be on the transverse axis and within the curve. Without knowing the exact value, I'm just going to kind of draw it 0C, and that is my 0, negative C. Moving on, I need my conjugate axis, which is my B, where my B's are. So B, negative B, 0, and I need my B, 0. Okay, so I actually have my rectangle right here. So whenever you got an equation of the hyperbola, this is always going to be the process of generating this curve, or finding out about the information about the features. So next, I need to draw my asymptotes. So let's connect the diagonals. I should actually use dotted lines. So here it is. Here's the other one. It's not super precise, but you kind of know the idea. It's connecting the diagonals. And in this case, let's see. That height is going to be A, and that height is going to be, that horizontal portion is going to be B. So in this case, my slope is not going to be B over A. It's actually going to be A over B. But I still have this point. So my equation would be y minus k equals plus minus a over b times x minus 8. I'm still going to use my center because my center will always be on both asymptotes. That's actually where they cross each other. So might as well use it to generate the point slope form. This is already more complicated, and I actually only showed you guys with the center being 0, 0. So we'll see when the center is not 0, 0 when we get to the examples. So let's move on. Example 1. There's nothing attached to the x or the y. That means my center is going to be 0, 0. My transverse axis will be the number that is positive, the variable that is positive. Clearly, my y squared is positive, so that is going to be my transverse axis. And I'm going to draw my center and also my transverse axis. My a is going to be the value that's under the positive variable. So that is going to be corresponding with the 9, so my a is a 3. Then that means the other value would have to be my b, which is a 4. It's not 9 and 16 because 9 is a squared and that is b squared, so I need the square root of them. C, well, c squared equals a squared plus b squared. So that means c squared equals 3 squared plus 4 squared, which is 25. So my c is going to be a 5. Next, my vertices. My a's are going to be my vertices. So since it's actually a vertical transverse axis, my vertices would be 0, 3, and 0, negative 3. So right here, 0, 3, and 0, negative 3. Oh, not there, 0, negative 3. Okay, I can actually kind of know where my curve is going to be. It's going to be this way, and with the vertices being 0, 3, and 0, negative 3. Foci, well, that is going to be using the value c value. So that is also going to be on the transverse axis, so it has to be 0, 5, and 0, negative 5. 0, 5, and 0, negative 5. Okay, now I have my my a values and my c values. Of course, I still need my b value so I can generate the rectangle. My b value is a 4, so that means my co-vertices would actually be 4, 0, and negative 4, 0. So 4, 0, and negative 4, 0 will be here. I can actually draw my rectangle. Drawing out the rectangle is kind of the best way to draw exactly where the asymptotes are. So now I'm going to connect. To be clear, I'm actually just going to use a solid line to label some points. So right here is my asymptote, one of them. The other one, I have all of these points. The other one is going to be right here. And the slopes, remember, is going to be related to my a and b. You don't have to memorize the formula. Just use the rectangle to find out the slopes. The center is 0, 0, and this portion is a 3. That portion is a 4. Rise over run, so my slope is clearly going to be 3 over 4. And the center is at 0, 0, so I can write it out. Y minus 0 equals 3 over 4. Well, plus minus, actually, because I have two different asymptotes, plus minus 3 over 4 and x minus 0. Simplified to be y equals 3 over 4 x plus minus. And I can draw my curve. My curve will be kind of approaching the asymptotes, so it doesn't have to be super precise. So here it is. That's kind of how it is going to be. And the other side, right here. It is going to having the vertices. And there we go. That's my hyperbola for example 1. Example 2. Well, this time the center is not 0, 0, so let's actually write down my center first. X value is going to be the opposite of negative 6, so a positive 6. The y value is going to be the opposite of negative 5, so a positive 5. That's my center. Let's find out. 6, 5. Right here. That is my center. Transverse, well, the positive number is still under the y. That means my transverse axis is going to be the y-axis, the vertical direction. So this is my transverse axis. A value is still going to be under the positive variable, so that is going to be a 5. B value is going to be under a negative, so it's going to be a 4. As for the C value, C squared is a squared plus b squared, and in this case, my a squared is 25, my b squared is 16, so that is going to be 41. So that means my C is going to be square root of 41. Let's actually find out the decimal value so that we can at least draw the points. It's around 6.40, okay, roughly. 6.40 is my C. But here's the tricky thing. The 6.40 is how far away it is from the center. So let me write that down first, and then we can actually start with the vertices. Whenever you're trying to find these values, we will always need to start with the center. So the center is at 6.5, and vertices would actually be 5 away vertically from the center. So let me draw them first, and then we can actually write down the value. This is at 5, so I need 5 away, which means I'm going to be at 10 and 0. So my vertices is going to be 6, 0 and 6, 10. Okay. Always use the graph, draw it first, and then you can actually find out the value. Because trying to calculate it is, it is kind of a lot to keep track of. Next, let's actually also find out about our B, so we can generate the rectangle. My co-vertices would be 4 away horizontally from the center. So to the left 4 and to the right 4. That is going to give me a 2, 5 and a 10, 5. Then for my foci, it's going to be 6.40 away from my center. So that is at 5. 6.4 is going to be 11.4-ish. So I can just write it as, you either use 11.4 or actually use the radical. So 6, comma, more precisely 5 plus square root of 41. And then the other one would of course be 5 minus square root of 41. So it's going to be around here. Okay. Now I have everything. I can start generating the rectangle and finding out my asymptotes. So here it is. There is my rectangle. I can connect the diagonals so I can generate the asymptotes. That is going to be 4 left and 5 down. So 4 left, 5 down, 4 left, 5 down. These are my points. And the other one, well, I can just use that. There's one of them. The other one, well, I'll just use these. Okay, there we go. The slope again is going to be, that is a 5, that's a 4, so it has to be 5 over 4 plus minus, of course. Now I can write using point slope form. My center is 6, 5, so y minus 5 equals plus minus 5 over 4 times x minus 6. In case you still haven't noticed, this part and that part, they're already in the equation. To make it simple, we are just going to use the point slope form. So you just need to use the rectangle to find out the slope. Now it's time to draw our curve. It's going to be around here with the vertices. The other side is going to be around here. Okay, there we go. It doesn't have to be super precise. But the asymptotes and the rectangle, you have to kind of draw these out to indicate exactly. At least a bit more precise. That's example 2. Moving on, example 3. Well, this time we don't even have a standard form of the equation. So the first thing we need to do is to make the right side a 1, which means I need to divide everything by a 16. That's going to give me x plus 2 squared over 4 over 16 simplified to be a 4 on the bottom, minus y plus 6 squared over 16 equals 1. Okay, well, finally, my transverse axis is going to be x because it's a positive number under the x value. My center, -2, -6. So let's start with that. -2, -6. Right here. And it's going to be a horizontal transverse axis. So I'm going to draw the transverse axis kind of around here. My a value, well, that is under my x. So that is going to be 2. My b value, that is under my y. So it's going to be a 4. And my c value, well, that is going to need a square and b squared. C squared is a squared plus b squared, which is 2 squared plus 4 squared, which is 20. That means my c is actually going to be 2 square root of 5, which is actually going to, well, we can keep the decimal so that we can at least draw the point. It's 4.47. So my C value, 2 square root of 5, or 4.47. Moving on, vertices. Same thing, let's actually draw it out first. It's going to be 2 away from the center, and it's a horizontal transverse axis, so 2 left, 2 right. We have -4, 6, -6, and 0, -6. My B is a 4, so I'm going to go up 4 and go down 4. That means my co-vertices would be -2, -2, and -2, -10. My foci, again, foci has to start from the center. So let's draw our foci. It's 4.47 away from the center on the transverse axis. So 4.47, it's around here. And to the right, 4.47 is around here. So I can kind of know, starting from -2, it's -2 minus 2 square root of 5, -6, or -2 plus 2 square root of 5, -6. These are my foci. So now I can actually draw my rectangle. It's going to be right here. I can draw my asymptotes. It's going to be 4 up, left 2 for this one. So 4 up, left 2, 4 up, left 2, 4 up, left 2. There it is. Just trying to generate more points, so at least my asymptote is a bit more precise. And the other one would be 4 up, right 2, 4 up, right 2, and 4 up, right 2. So here it is. My slope, well, it has to be this triangle right here. That is 4 and a 2, so that means my slope is 4 over 2, which is a 2. But I still need to use my center to write my asymptotes. And remember, use the x plus 2 and the y plus 6. So it's going to be y plus 6 equals plus minus 2 times x plus 2. Finally, I can draw my curve. It is going to be, with the vertices, well, he's kind of make it into a curve. It's a pretty wide open curve, like that. Okay, there we go. That's example 3. Well, this time moving on, example 4 and 5, we need to use the given information to write the equations, which is actually a bit easier. So because we just need to identify the A and B, we do not have to identify the C, because in the equation there's no C. For the first one, you can clearly see it is facing left and right. That means the general form would have to be x minus h squared over a squared, and y minus k squared over b squared equals 1. So you are always going to need to check the direction to know which standard equation you are using. So now I just need to find out my h and k first. That is at 0, -2. So that means my h is a 0, my k is a -2. So at least I know my equation is going to be x squared over something minus y plus 2 squared over something. Remember, it's always going to be the opposite value for from the center, equals to 1. Now I need to find out my a and b. So you kind of just need to know where the rectangle is. In these graphs, you kind of can tell there's some bold lines to actually show you where the rectangle is. But let's say you are trying to find the rectangle by yourself. First, you are going to need to identify the vertices. These are going to give you the a values. That part, that part. Because 2 vertices are 2a away from each other. And there's 1a away from the center. 1, 2, 3, 4, 5. My a is 5. That means it's going to be a 25 under the x squared. Now, you have already learned how to generate the rectangle if you are just given an equation. So now we're kind of going to think backwards. We are still going to use, well, not quite backwards. We're going to think the same way. We're going to use this point, start drawing lines. And this time, the difference is the asymptotes are already given. So wherever these lines are crossing the asymptotes, that's where the other side of the rectangle is going to be. So clearly, these are the points for my other side of the rectangle. Now I can clearly identify my b's. I already know my a, that's my 5. My b would be right here, 1, 2, 3. So my b would be 3. That means it has to be a 9 under y's in this question. And that's it. That's my standard form of the equation. It is more about identifying where that rectangle is. So let's move on to example 5. That is opening up and down. So that means my standard form equation would have to be y minus k squared over a squared minus x minus h squared over b squared equals 1. So now I can start by identifying my center. My center is -1, -3. So it has to be y plus 3 squared. Remember, it's always going to be the opposite value of the center over something minus x plus 1 squared over something equals to 1. Now let's identify our rectangle. My vertice, well, it's a bit hard to tell, but remember, vertice is going to be on the same transverse axis as the center. So it has to be here and here. And they are 1 away from my center, so my a is 1. That means it's a 1. Next, I'm going to use that point to generate the rectangle. I'm going to draw a line across the vertices. Then you can see it's crossing with the asymptote at these points. That's exactly where my rectangle is going to be. So now the other, if that's a is 1, 1, 2, 3, 4, my b is 4. So it's going to be a 16. When you write the final form, you do not have it 2 includes over 1. But that's how the equation is going to look. And that is example 5. Moving on, example 6. This time you are given the vertices and you are given the foci and is asking to write equations. So let's we don't have to draw a full graph, but at least we need to generate to find out a general idea. 7, -4. Let's say this point is 7, -4. -3 and -4 would be to the left of it. These are my vertices. So I can clearly see my center is going to be right in the middle. You can kind of draw this to find out where your center is, or you can use the midpoint. The midpoint would be 7 plus -3 over 2. And -4 plus -4 over 2. Adding the x values, then divided by 2. Adding the y values, then divided by 2. That is going to give me a 4 over 2, so 2, -4. That is where my center is, 2, -4. And then I can use my foci. My foci is going to be on the same axis of my vertices. You can clearly see my transverse line is actually horizontal. So I can at least write part of the equation already, x minus 2 squared over something, and y plus 4 squared over something equals to 1. As for that something, we can at least find out a first, because this is a, and that is a. My center is a away from my vertices. That is 7, -4, so clearly it's 5 away, so my a is 5. That is going to be a 25 under x minus 2 squared. Now, my foci, it's 8, -4. Oops. So let's see. Where's my line? That is my transverse line. My foci is 8 -4. Remember, this point is 7, -4. My foci is 8, -4. So I can clearly know my c would be a 6 in this case. So I can use that to find out what is my b. C squared equals a squared plus b squared. That means 36 equals 25 plus b squared. So my b squared would have to be 11. I don't even need to find out the square root of 11 because I need b squared under the y. 11, right there. And there's my equation. So a simple diagram doesn't have to draw the curve or the asymptotes. The simple diagram is just indicating the relationship between A, B, and C. So moving on, example 7. Vertices in this case, -3, 1. Let's say this is -3, 1. And -3, -7. -3, -7 would be below. Okay? That means my transverse line is right here, a vertical one. So if that is -3, 1, and this is -3, -7, right in the middle, -3 plus -3 over 2, and 1 plus -7 over 2. That's going to give me my midpoint as -3, -3. So my center is -3, -3. I can write it out, y plus 3 squared plus, not plus, minus, well, over something, minus x plus 3 squared over something equals to 1. And again, I know it is going to be y in the front because when I connect these vertices, it's a vertical line. So that means my transverse axis is actually vertical. That's why it has to be y that's positive. Next, my foci is -3, 5. So -3, 5. And I don't even need the other point because I just need to find out my c. My c in this case, 5 and -3, they're 8 away. And I did forget to identify my a. My a is basically from 1 and -3, the distance between them. So my a is a 4. A is 4, that means it's going to be a 16 in the front. Next, c squared equals a squared plus b squared. My c is 8, so 64 equals, my a is 4, so 16 plus b squared. That means my b squared would have to be 48. There we go. That is example 7. Last two, example 8 and example 9. Example 8, vertices 3, 6, and 3, 2. So let's draw these out. 3, 6. 3, 2 would actually be below. Well, not -3. A positive 3, 2. The point in the middle, well, first, my transverse axis is going to be horizontal. The point in the middle, you can use the midpoint or just kind of identify from here. It is going to be 3, 4. So y minus 4 squared in the front over something minus x minus 3 squared over something equals to 1. I can identify my a. The points are 2 away, so my a would have to be 2. If my a is 2, that means it's going to be a 4 under the y minus 4 squared. As for my b, conjugate axis length is 8. The length of each axis would be either 2a or 2b. In this case, that means 2b is 8. So my b is a 4. That means it's going to be a 16 under the x minus 3 squared. Example 9. So this is a general equation, and we need to turn it into a standard form, which means we are going to do completing the square. Let's put all the x and the y's together first. 4x squared minus 24x, leave a space, minus 49y squared minus 196y, leave a space, equals to, moving the negative 356 to the right is going to be a positive 356 and 2 spaces. Next, if I actually want to complete the square, it will be easier if it's just x squared and y squared. So I'm going to factor out the 4 for the x squared and the 49 for the y squared. Factor out the 4, I have x squared minus 6x with a space. Minus 49. Remember, I'm not just factoring out the 49, it's factoring out the negative 49. So I have y squared, and that negative 196, when you factor out the negative 49, becomes a positive 4y, and then a space. Equals to 356, still 2 spaces. Now let's figure out what's going to be in the spaces. Negative 6 over 2 is a negative 3, and square it is going to be a 9. However, when we want to balance it on the right side, it's going to be a 4 and a 9 together. So it's going to be a plus 36. Next, it's a 4. So 4 divided by 2 is a 2. Square it is going to be a plus 4. However, in order to balance it on the right side, it's a negative 49 multiplied with a 4. This is going to be a minus 196 on the right side. Now I need the squares. 4 times x minus 3 squared minus 49 times y plus 2 squared. Again, inside the parentheses are going to be these numbers right after we divide them by 2. As for the right side, it is going to be 196. But I need the right side to be a 1, so lastly, we are going to divide everything by 196. So finally, x minus 3 squared over 49 minus y plus 2 squared over 4 equals to a 1 on the right side. And that is my standard equation for example 9. Whew, finally, that is everything for hyperbola. It is more complicated than the other sections, but if you kind of go through or follow the process, it shouldn't be too bad. So that is everything for this lesson. Thank you.